بسم الله والصلاة والسلام على رسول الله. Ladies and gentlemen, welcome you today. It's a great pleasure to introduce Dr. Fidel Castro Diaz-Balart. Dr. Castro graduated with a Master of Science in 1974 in physics from the State University of Moscow. From 1972 to 78, he carried out research in nuclear physics in the Joint Institute for Nuclear Research of Dubna, and earned his PhD in physical mathematical sciences in the Kurchatov Atomic Energy Institute in Russia. Afterwards, he did postdoctoral work in theoretical physics and nuclear power plants based on VVER reactors. These are the pressurized light water reactors. And in year 2000, he obtained a Doctor of Science degree from the Higher Institute for Nuclear Science and Technology in Cuba. He also holds a Master in Science, equivalent degrees in Strategic Planning and Higher Management and Project Management from recognized institutions in Russia and Spain. In his professional experience, he held senior positions in Cuba from 1978 to 92 as Executive Secretary of the Atomic Energy Commission, and to the government body Executive Secretariat of Nuclear Matters. From 1993 to 2003, Chief of Scientific and Innovation Activities in the Ministry of Industry. From 2004 to the present, Scientific Advisor of the State Council, Republic of Cuba. He headed the Cuban delegation as a governor in the governor board of the IAEA and had numerous contributions in the field. He wrote 11 books related to atomic energy and also to innovation, science and technology, and knowledge economy. We are extremely delighted to have him here with us, and we hope that we can build collaborations based on this visit. So we all please join me to welcome Dr. Castro.
Good morning. His Excellency Dr. Mohammed bin Ibrahim al-Suhaili, President of Kacst, His Highness Turkey bin Said bin, and Dr. Abdulaziz al-Suhaili, Vice Presidents of Kacst, member of the chair and guests, ladies and gentlemen. I should start by acknowledging how honored I am by the invitation to visit the King Abdulaziz City of Science and Technology and the possibility to address this distinguished auditorium, for which I convey my gratitude to the authorities and representatives present here. As an introduction, I should comment that we are in a globalized world with huge contradictions and social inequalities, in a time characterized by the scientific technological advance and the importance of the technological innovation growing in the production of goods and services worldwide. The emergence of knowledge economy, supported in diverse leading fields, is result in an increment of the core add value that depends more and more in a better knowledge use, no matter the level, form, or origin of the development. the innovation is no longer a linear process that comes up from an advance in science which later influences in technology, production, and market. It depends now on the means constituted by many areas of the interlinked scientific and technological knowledge, and in contrast, feedback what shortens the distance between the scientific result and the new technology incorporated to the production. But as you know, knowledge is rarely applicable directly and immediately, and as a productive resource, it requires for its assimilation of the technological innovation of a system of science and innovation intelligently and efficiently connected with the production mechanism. However, it's necessary to stand out that the technological development is determined by the arbitrary richness distribution, the polarization of the social development, and the existing economic imbalance, where the world's population, fifth part that lives in the richest countries, control the world resources and consume the 80% of the world energy resources, whereas to the rest, if only correspond the 20%. The reality is that out of those almost 5,000 million people that inhabit the developing countries, 800 million don't have enough food and medical care. Almost 900 million people are illiterate, and 1,200 million survive with less than $1 per daily in more than 110 countries of the world. Therefore, in the denominated knowledge economy era, there are key features that seek to minimize system affliction, as the exclusion of opportunities, the appropriation of knowledge, and the brain drain, euphemistically named talent migration in many forums. I would like to begin dealing with the current role of science and technology in Cuba. In the mentioned scenario, complex scenario, submerged in a convulsive and unstable world, what could be expectation of a small and underdeveloped nation like Cuba to participate and to use modern science and high technologies in benefit of their society? To understand the nation's current stage of development in science and technology, we should look at the achievements that have made it possible. In a short summary, I will try to show the work achieved in more than half a century in the context of the reality of having faced big internal and external obstacles. Cuba, as you can see, is an archipelago of 110,000 square kilometers with around 11.2 million inhabitants, distributed in 14 provinces. Its GDP is about 45 billions of US dollars. Starting with the sphere of education, in 1959, the country had a population of 6 million inhabitants and approximately 30% illiteracy rate. It only counted with 3 universities and 17,000 students, from where, based on resource, race, and gender, the great majority, except for exceptions, was excluded. Today, there are 68 higher education centers, where more than 300,051 students, out of them 58% are women, studies. It has a cluster of 77,400 professors, and traditional walls of university have been overtaken by a 123 university network centers in 139 of the country's 169 municipalities. From 1959, the country has formed around 200,000 professionals, representing about the 15.5% of the Cubans with the highest student studies completed and uncompleted with regards to its grown-up population. Science and innovation is another national outstanding. Science and innovation is another national outstanding activity linked to the development, and its main indicators are shown in the slide. The total expense of R&D in Cuba is at the level average for Latin America and the Caribbean, around 0.64% of the GDP in 2009. The country already counts with 10.4 scientists and researchers for each 10,000 inhabitants. Economically active include 943 doctors in science per million, respectively. In the sector work more than 74,000 people, more than the half is women. The nation has 18,000 masters in science and close to 10,500 PhD in specific branch and around 300 doctors in science of second degree. It exists an infrastructure of 119 research centers and the most diverse area of the scientific activity, the economy and the humanistic study. The strategy regarding research has been centered in the national branches and territorial programs, having the best priority and financial support. In these years, important scientific results have been reached in the most diverse branches of science, technology, and knowledge field. Two examples, tienes que pasar la otra. Esa iba después, pero bueno. Excuse me, something. Two examples worth noting are information and telecommunication, ICT capacity building in education and science and technology, impact on different branches of industry. On ICT, an indication of the true scale of this effort is that around 100,000 computers equipped with multimedia and peripherals have been bought and distributed to all schools in spite of the economic embargo imposed on Cuba from abroad, recently condemned at the United Nations by 188 countries. The above mentioned involved the installation of solar panels in 2,368 primary and secondary schools, polytechnics, and other higher education institutions in remote places throughout the country. Regarding some innovative achievement of Cuban industry, it should be mentioned the adaptation and modernization of import science and technology, which has revitalized local technology. For example, modernization of all countries' power stations, a process which enabled Cuba, starting in 2003, to generate nearly 90% of its electricity requirement using Cuban crude oil. Also, deep-sea oil prospecting conducted in cooperation with foreign companies at depth exceeding 2,000 meters, an activity which plays an important role in the expansion of the oil industry and their integration into the new economy. Technological innovation and the adaptation of transfer technology has been also benefit other sectors of industry, such as cellular telephone service, where the country has currently more than 1.5 million users, and the design and infrastructure manufactured in Cuba several high technology equipment items which are being used in the national healthcare system and exported to many countries throughout the world. Medical application, however, is the undeniable achievement in healthcare, where science and technology has been more social impact. As you can see there, these are data from abroad. The greatest indicators of doctors per inhabitant of the planet, 1 per 165 inhabitant, and infantile mortality close to 5% born alive, and a life expectancy of 70.6 years. There are around 30,000 doctors and other health personnel in more than 60 countries. Besides, it is internationally recognized that with a 355 per capita in health, is 7.1% smaller than USA and Europe, Cuba has achieved one of the best levels of children's and adult vaccination in the planet. The role of biotechnology. In pursuing this task, biotechnology has played an outstanding role. From January 1981, with the opening of a laboratory to produce interferon, when it hardly appeared in the most developed countries, the Cuban government, without any foreign venture capital, founded the Western Scientific Cluster that grew quickly with new institutions and products. After 31 years, it became what is today the most important scientific node in the country, originally linked to the health system. It's conformed by 27 entities, which includes, which nucleus is formed by 10 institutions. As you can see here, this is the first institute that was built in Cuba in 1965. It's the National Research Center. It was built almost, 45 years ago, or almost 50 years. This institute was built when in Cuba, only 3 years before we had launched a campaign to end illiteracy. And many people didn't understand why a country with those conditions should create this kind of institution. It's a matter of fact that 15 years after, when it was need to boost the biotech, the science leaders grew here. They were bred here. Well, they obtained their doctorate and master's degree in many universities of the world. But after that, they started to build different centers. And now we have the biggest one is the Center for Gen Engineering and Biotechnology. I will say shortly about their product. The Center of Molecular Immunology. The center, a big pharmaceutical plant based in 3- and 4th generation vaccines. What else here we have? The Institute Finlay. I don't see it. I think he's Ipaga here. Where it's produced the vaccine for B and C meningococcal vaccine, is unique, effective in the world, and so on. So now they have 52 institutions, workers almost 11,000, university degree 3,000, researchers, a total of, it's a big, 10% of them are PhD, and totally they work. So I was saying, after 32 to 31 years, these more than 10,000 workers operate plants in Cuba and transfer abroad and carry out operation of several $100 million yearly. Something important to highlight is that the success reached in this sector have been mainly fruit of the effort and creative talent of Cuban scientists, professionals, and workers, and the vision and constant support of its historical leader. The cluster operates with the following strategy. Go back. ¿Lo tienes aquí? Okay, let this one. As you see, closed-loop organization from the idea to the product. Export-oriented organization building off of intellectual property platform, and a tight relationship between research and the industrial strategy. This has provided the development of more than 70 novel products and are correctly protected under industrial properties law, almost 1,000 patents in more than 60 countries. Some of these are unique in the world. I can show you here. Everprop P, for example. This is a product devoted mainly for the disease, the so-called diabetic food. If it provides the opportunity of not making an amputation in more than 90% of the cases. It's a very important product. It's the leader product currently of that Center of Gene Engineering. This vaccine, meningococcal BC, has been exported to many countries and has, in tight relation with Brazil, gone to many countries as Africa, wherever the meningitis appears. This is nimotuzumab, is the name of a humanized antibody monoclonal that is used for throat and cancer and lung cancer, and is registered in many countries, and now is going beyond this. They have other products related to prostate cancer and so on. And SUMA is ultramicroanalytic system that has been devoted already for more than 25 years, different generations, is used with little quantities of reactive to see the DNA, the blood, the quality, and many things that can be very fast. They use here actually in the last generation some nanotechnology embedded there in their equipment. So the past success reached in the new products development has powered the transfer of technology to other countries and country access to the external markets, including the developed world, in terms of novelty, quality, production volume, and joint business. You see here in China, we have here is for hepatitis B vaccine and other vaccine in Changchun province in the north. In Beijing, they have a joint venture with the Center of Immunology, Molecular Immunology. In Brazil, they have also different, this is a joint corporation, and in the Basque country, they are producing this heavy product also and giving, they are in the final clinical stage to register in Europe this product that is also being registered in Japan and North America. The past, so for the development, for the current development of the country, the main effect is the conversion of this paradigmatic national biotechnology industry in a new economic sector based on high technology companies with production plants and trace entity of state property, named BioCuba Pharma, due to its fusion with pharmaceutical industry. So the scientific cluster, I say, together with the traditional chemical pharmaceutical industry have fusion, and they now produce, they are combined the second yield of hard currency in the country. So when I was talking about knowledge economy, you have an example of what it means in practical terms in our country. Regarding nanoscience and nanotechnology role in the future development of the country. What role the application of nanotechnology will play in the context of deep economic social transformation? A study of the MIT, as you see here, that refers to the 10 advanced technology that will change the world in the 21st century, shows that a high proportion is linked one way or another to the nanotechnology. The main industrialized nation with resources to go into all these technologies has focused advanced materials, mechatronics, soft, hard system for grids, etc., to keep and to increase the competitiveness in the aerospace, armament, production of vehicles, the micro nanoelectronic industry, etc. However, at the present time, more than 50% from the resources to world scale are devoted to human health application. In particular, the nanobiotechnology occupies a key place among the candidates to solve pressing problems of health in the world and in particular in the developed nation, with more precise and effective methods of diagnosis and prevention for a better treatment of multiple diseases. It is reasonable, here we put nanomedicine, that for their social impact, the service Cuba offers in more than 60 countries, and the well-known achievement in the health and biotechnology, that nanomedicine and nanobiotechnology will be the essential point of the national development without overlooking the important field of energy and environmental studies. Therefore, it is understood that the nanoscience and nanotechnology are strategic areas for the development of the country and could be an efficient contribution to the express purpose. I'm not referring to the near future, but to the vision, to the development of the necessary technical productive infrastructure and the effort that should be carried out nowadays to achieve the above mentioned, because the new knowledge and technological changes are taking place to such a rhythm that we could be permanently excluded. We should take in mind that the progress of the Cuban magnificent biotechnology industry that I showed you before, under economic crisis conditions, financial stress, and external blockade, needed more than 25 years to consolidate. At the present, Cuban government bets to the nanotechnology as a transcendent area to be competitive and to reach a future sustainable development based on the intellectual properties. The reach of the program appears in the screen. Its main objective is to remove the disciplinary boundaries, to provide opportunity to stimulate the research topic integration with the universities, research institute, and niche in high technology companies, paying special attention to nanomaterials, nanoparticles, nanowire, nanotube, and material for energy, environment, nanodevices, nanobio, etc., and to the tools for nanocharacterization, as you well understand. One of the essential elements for the implementation of this objective, whether here is the creation, is the Center for Advanced Study of Cuba. As a national multi-user facility and equipment platform with the state-of-the-art tools, both critics for research, development, and innovation. The first stage of SEAC will be finished by 2013. Its vision and mission is shown in the slide. Is to become an advanced international level institution with a tangible impact on Cuba's development in bio-nanotechnology and new application in energy and environmental control. And the mission is to assimilate, generate, and transfer the new knowledge and state-of-the-art technology for the scientific progress of Cuba and for exchange with other countries of the region and worldwide, I can say, no? But mainly certainly for the region. Its characteristic, general characteristic, is an institution with an open and multidisciplinary nature devoted to the development of the essential nanotechnological application in the life science, environmental energy, and is a unique infrastructure with ultra-low vibration condition, without electromagnetic interference, powerful computer infrastructure, world-class laboratory for nano characterization, and so on. With this infrastructure, SEAC will be able to achieve important R plus D and N plus I results, innovation, to multiple integrated application of academic and industrial interest. As you see, with material, process, and packaging, they have a matrix of different applications that we can have in this center when it will be full-fledged working, we hope in the next 2 years. The center will promote the participation of national entities and institutions in the program in this field, and we will be open for scientists and academicians of different nations, in particular of Latin American area, but not only. We expect to have some interchange, as we talked today with the top management of these institutions. In the future, we can have some interchange in this field also for mutual benefit. Allow me then to conclude this presentation with one of Jose Marti, our national hero, beautiful thought that illustrates as known the intelligence and necessary determination to face forthcoming challenges. To be man is more than be a word, alive, is to understand a mission, to ennoble it, and to fulfill it. Thank you for your attention.